So what are we going to do? We're going to obtain 4 ion samples. All right. We're going to label our test tubes, prepare the chromatography paper according to the instructions that are in the lab manual. We're going to spot the compounds onto the paper and develop them, measure their RF, and then we're also going to look at an unknown sample, which I'll have you. We're also going to look at an unknown sample, which I'll have you to identify, and we're going to do the visualization. And the beauty of it is that it's all virtual. So here are my solutions. I have a copper 2 solution. So this solution is filled with copper ions. I have a nickel 2 solution. So it's filled with nickel ions. An iron 3 solution. So that's filled with iron ions. And then a cobalt 2 solution that's filled with cobalt ions. So I've prepared my chromatography paper. I have an X here in each panel, just like the lab manual instructs us to do. And I have a line 1 centimeter from the bottom of each panel and of chromatography paper. So now here's my iron. I'm going to spot that onto the chromatography paper. I dip the capillary in, bring that over, and I spot it on the X. And now I have my iron spotted above the 1 centimeter line. Then I'll bring in nickel, and I'll go ahead and spot that on the chromatography paper. Then I'll bring in my copper ions, and I'll go ahead and spot that, and it'll be spotted in the third panel. And then I'll bring in my cobalt ions, and I'll go ahead and spot the cobalt onto the chromatography paper. All right, and now it's time to develop it. So I have a beaker and a watch glass. That's my developing chamber. I'm going to use my acetone HCl solvent mixture as the mobile phase, which is going to be used to drag again the compounds up the paper through capillary action or wicking action. And now I just watch as the spots move up the plate. Notice the iron move really quickly, and then the cobalt moved really quickly, but the copper and the nickel did not. Let's look at those again. So watch again. The iron is flying up the chromatography paper, so is the cobalt. But you see the copper and nickel are moving a lot slower. So let's talk more about that. So now we're going to test to see which one of these were actually hydrates, right? We already talked about cellulose grabbing onto those hydrates. Let's go back again. If we look at the spots again, the ones that move really slowly, that means that they're really sticking to this chromatography paper. The ones that move quickly, that means that they're not sticking very well. So when we look at the test for metal aquo complexes, what we're going to do is expose that chromatography paper to ammonia and see if any of those spots actually change colors. So the cellulose, we already talked about how it grabs onto those hydrates, right? If it's a hydrate, it's going to move a lot slower. Um, and if and again, a hydrate is a metal with water bound to it as a ligand. All right, a ligand is just a complicated word for a water or any other molecule that's bound to a metal using a pair of electrons. All right, if we test this chromatography paper with ammonia, any hydrate is going to turn dark blue. And if it's not a hydrate, the other possibility for the case of this experiment is that it's a chloro complex, which means it moves up the plate rapidly. Right. So let's look here. Right. Ammonia can react with hydrates in a couple of ways. Before we actually show you the test, let's talk about this. So it can react through what's called proton transfer or deprotonation. That means you remove H plus from one water molecule of the hydrate, and I'm going to show you that. It can also react with the hydrate by doing what's called ligand replacement. Again, a ligand is just a group like an atom or a molecule that's bound to the metal using a lone pair of electrons. So ligand replacement, you end up replacing one of the water molecules with an ammonia molecule. So I'm going to show you both of these processes. So the way proton transfer works, here's my metal hydrate. It has 6 waters around it. Here's my ammonia. If you look at the other side of the equation, the O8, one of the H2Os has lost an H, right? That's because NH3 has pulled off an H. So you have an OH and then H2O, and 5 of those now no longer 6, and then NH3 becomes NH4. Now let's look at that and see how that actually works. So this is what the metal hydrate looks like. It's actually an octahedral complex with 6 waters around it. Right? I'm going to bring in ammonia, and ammonia is going to give that pair of electrons to hydrogen, and then the OH bond is going to break, and those electrons go back to oxygen. Right? Now let's look at what happens. So here is the OH, right? This water lost the hydrogen, so now it becomes OH, and then the NH3 has actually gained a hydrogen by removing this hydrogen from here, and so now it becomes NH4 plus. Right? Now let's talk about ligand replacement. Right? Look at the equation. I have 6 waters. I have 3 moles of ammonia to this 1 mole of this metal hydrate complex. I'm going to replace 3 of these waters with 3 ammonia. So that's what this, if you look on the other side of the equation, I have a metal hydrate, right? It's a trihydrate. It was a hexahydrate. Now it's a trihydrate with 3 NH3 groups attached to it. And then I lost 3 water molecules from here. So that's where I have now 3 moles of water. So let's look at how this works. Here's my hydrate. Here's 1 ammonia coming in, and that's going to attack the metal and kick off the water, right? And then that's going to happen again. Here's my second ammonia coming in. It's attacking the metal, and it's forcing water out. And then my third ammonia comes in, and that's also attacking the metal and forcing out water. All right. Now let's look at what happens on the other side of the arrow. You have a nice dark blue complex. You can see that now you have 3 ammonias attached to that metal, whereas you had 6 waters over here. Now there's only 3 waters, and then there's 3 ammonias, and then you lost 3 molecules of water from that hydrate. And so that's what this 3H2O represents here. All right. So we've already developed our plate, and now we've added ammonia to the developing chamber. We have a new developing chamber. We've added some ammonia to it, and let's recall what our spots are. Obviously, this is iron, this is nickel, this is copper, and then this is cobalt. Right now, let's watch what happens as these ammonia vapors kind of saturate the developing chamber. You can see that 2 of your spots actually turn dark blue. Right? So what does that mean? Well, ammonia turns hydrates blue, right, by ligand displacement. So what happens is, if it's a hydrate, the ammonia comes in, it kicks off water and replaces it, and so those complexes show up as navy or dark blue. Right? So now let's talk about the calculation of the RF values, and this is something that you're going to have to do. Again, the RF, or retardation factor, it's a unitless value as long as the 2 numbers have the same units, right? Centimeters or inches or however you want to measure it. And it helps us to determine the polarity of compounds or the affinity of a compound for the stationary phase, right? And it's calculated using this little formula down here. We've already talked about that. So now let's go on to here. We've talked about this already. So now let's look at our plate again. Here are our compounds again: iron, nickel, copper, and cobalt. They're in that order. And here's a table with the different ions and the distance that they travel and the distance that the solvent travels. So you're going to have to go in and calculate these RF values on the quiz that you'll take after watching this video. Right? Here's an unknown question. It says determine the following unknown. It was spotted on chromatography paper, had an RF value of around 0.35, and it turned dark blue upon exposure to ammonia. Which of the 4 ions does the unknown most closely match? When you go take the quiz, you'll answer this question. All right. What do you need to do now? You need to go into the paper chromatography folder under assignments, and then you need to click on the quiz that's there, and you need to complete it. But only do it after you finish this video. All right. If you have any questions, you can email me, you can call me, or you can come by the office and ask questions as well. So if you have any questions, let me know. Thanks.